geography और public administration में कौन सा subject ज़्यादा मुश्किल है या कौन से ज़्यादा
geography is a bit tougher. To write answers in geography, it is a bit tougher. Not physical geography, but to write answers of human geography, it is a bit tougher. You need a lot of current affairs to data to substantiate your point. With public administration, you need more of current affairs, but not much of data. Like in geography, if question is being asked related to, let's say, migration, let's say question is being asked regarding settlement pattern, so data has to be given. So sometimes what happens is you don't have in examination, if you're reading for examination, sometimes you go for writing in the examination, data doesn't comes in your mind, because everything you have to write different sessions, like history you also have to read, revise, other things also have to be revised. So difficult to score marks in that particular subject, and you need a lot of practice for that. For that data, if you are interested in that, okay, data you can note it down separately, and once on the examination day you revise all the data once, so that okay, when you are going in the examination, it is fresh in your mind. So that is okay there. In case of public administration, a lot of current affairs has to be involved, because the administration keeps on changing. New policies keeps on coming, new type of technique keeps on coming. So in there also current affairs has to be involved while writing answers. But it is more concise part. Like in public administration, don't have to read about world administration. You only have to read about Indian administration. In geography, you have to read from both world perspective also and Indian perspective also. So that makes it more broader. Geography is a more broader in terms of syllabus part. So that's where geography is a bit tougher, because they may ask you like a location of iron and steel industries in India or location of iron and steel industries in the world. So you have to keep that in mind in USA where it is located. You have to give examples of UK. You have to give examples of, let's say, South America, African countries. So that's where a lot of information you have to keep in mind. So that way writing answers for geography becomes a bit tougher as compared to public.
So I'm thinking of taking public administration. I'm sure that I'm not doing my offshore education. So I'm thinking to start it.
You started basic reading, you started, so that you have an idea about what is administration, what is basic administration, that you can start.
So generally, how do you manage this part for me, because there are so many subjects to do, and only about 300 days are left for this part.
Yeah. See, there are two things. One way is okay, attending, like when you are attending coaching and you are doing self-study, you attend the coaching, and whatever the subject being taught in the coaching, you try to orient your preparation with that. Like geography is going on, so you try to cover geography with current affairs. Don't focus on other subject, okay, much. That is okay there, because you have not been taught that particular subject, difficult to understand that particular subject. So one way is okay, you orient your preparation with the subject that is being taught. Or the second way is okay, you can start reading NCERT for every subject, that is okay there. When and wherever you are finding, complete the static part first, like history, geography, economics, and etc. Then go for current affairs part. Clear? So that is the second way. But I'll suggest, because okay, you are reading, attending coaching right now, so attend this as well as read this particular part in detail, try to solve questions related to that, try to write answers related to that, so that once you are shifting to the next subject, you are already covered with what you are already having a solid knowledge. You have already covered important areas of these particular part. Right? So in the last class, we started with the concept of cyclones. We covered tropical cyclones in the last class. Also, we discussed the concept of lightning, thunderstorm, and we also covered the concept of precipitation. So these are the concepts we have covered in the last class. So why lightning struck the people and etc. Why lightning struck? What is the reason behind lightning striking people? Yeah, it tries to take a easy path. So we discussed, since the air is what? Air is a bad conductor of electricity. So when lightning is going through the air, if it encounters any building, if it encounters any trees, or if it encounters any people, so then it falls on that, because they act as a good conductor rather than the air, because air acts as a bad conductor. So this we have discussed with regard to what? This we have discussed with regard to lightning. Clear? Next is we discussed thunderstorm. What is thunderstorm? What is a thunderstorm? So we discussed when there is an intense rainfall with thunder and lightning, short duration intense rainfall with thunder and lightning. It is called as what? It is called as a thunderstorm. And we discussed one of the name for thunderstorm. What is thunderstorm known as in USA? So we have used the term twister. Twister, where the term that is used for what? Thunderstorm in case of USA. So that we have discussed. We covered cyclones. What is cyclones? What is cyclones? What is the cyclones? What is the definition for cyclones? Yeah, atmospheric disturbances. Around low pressure. Atmospheric disturbances around low pressure causing what? Causing inward rotating wind. So this is what definition we have discussed with regard to cyclones. It is atmospheric disturbances around a low pressure center causing the inward rotating wind with a high velocity. Inward rotating wind with high velocity. This is what we referred as a cyclones. And we discussed the cyclones can be divided into two types: temperate cyclones and tropical cyclones. Tropical cyclone we discuss occurs between what? Between 10 degree to 30 degree latitude. So northern latitude or southern latitude. So it occurs generally between 10 to 30 degree northern and southern latitude. We discuss what is the structure of tropical cyclone. What is the structure of tropical cyclone? Eye region, eye wall region, and spiral band or rain band region. So we discussed this is how. So this is okay. What this is a eye region. This is eye wall region, and we discussed around this various spiral band region. This is a structure of tropical cyclone we have discussed in the last class. Then we also discussed what? We also discussed the conditions in which tropical cyclones are being formed. So we discussed why tropical cyclone do not form at the equator between 0 to 10 degree. Why tropical cyclone do not form between 0 to 10 degree? Because there is no Coriolis force. So we discussed no Coriolis force. One of the conditions for tropical cyclone to form is what? Coriolis force. So since there is no Coriolis force, tropical cyclone do not form between 0 to 10 degree. We discussed when tropical cyclone more occurs. No, tropical cyclone is between 10 to 30 degree, not near poles. Where do you see more tropical cyclone occurring? Where do you see more tropical cyclone occurring? In this latitude, 10 to 30 degree latitude. And we discussed when tropical cyclone will occur. It generally occurs during late summer. Remember, we discussed late summer is when tropical cyclone is more occurring. Like we discussed which was the cyclone that has recently occurred. Naming of the cyclones we have discussed. So which is a cyclone that is a recently occurred? Fengal. Yes, okay, Fengal occurred. Okay, the last one. Then after that, Fengal, what has occurred? Cyclone Shakti. Who has given the name Shakti? Sri Lanka. And next cyclone is going to be called as what? Monta. Yes, okay. And who has given this Monta name? Thailand. Yes, okay. So this naming of cyclones we have discussed. And we discussed cyclones are also known by the various local name, where they are known as typhoon, Japan, where they are known as hurricane in Atlantic Ocean, and where they are known as a Willy Willy, Australia. Yes, okay, so those parts we have discussed. So we have covered tropical cyclone in the last class. We'll start with temperate cyclones today. Fine. So the first thing regarding temperate cyclone, what you have to keep in mind is the temperate cyclone occurs in which region? They occur generally between 35 to 65 degree latitude. So they occur generally in this region, or 35 to 65 degree latitude. So they are the tropical cyclone. They occur generally between what? 10 to 30 degree latitude. Temperate cyclones occurs generally between what? 35 to 65 degree latitude. It is more prominent in the northern and southern hemisphere. It is more prominent in northern hemisphere as compared to southern hemisphere. That is okay there. Clear? So temperate cyclone, you have to keep in mind, it can occur between 35 to 65 degree latitude. Fine. Now, why the temperate cyclones forms? It forms due to frontogenesis, and there's a term also called as a frontolysis. So temperate cyclones are formed due to frontogenesis process. It is formed due to frontogenesis process. Clear? So there are two terms. One is called as a frontogenesis, another is called as a frontolysis. So temperate cyclones are formed due to frontogenesis process. So what is the essential condition for formation of temperate cyclone? First thing, you require two contrasting winds. Second, frontogenesis need to happen. The third thing you require is what? The third thing you require is presence of Coriolis force. Fine. So if these things are present, then it is going to form what? Then it is going to form temperate cyclone. Two contrasting wind. Second is what? Frontogenesis. The third is what? Presence of Coriolis force. If these three are present, then temperate cyclones will occur. Fine. So what is this frontogenesis? Frontogenesis stand for, genesis means what? Origin. Something that is originating. That is called as a genesis. And what is originating? Fronts are originating. So when fronts are originating, we call it as what? We call it as a frontogenesis. When fronts are originating, we call it as a frontogenesis. And frontolysis is once front are dissipating. When front are dissipating, then it is going to be called as a frontolysis. So there are two terms, frontogenesis and frontolysis. Frontogenesis means fronts are originating, and frontolysis means what? Fronts are dissipating. Clear? Dissipating means what? They are no longer there. They are dying. That is what we call as a dissipating. Clear? Now, what is this front? So what is front? Basically, it is a three-dimensional boundary. Front is what? A three-dimensional boundary which is formed when two contrasting winds are converging. When two contrasting winds are converging, it is a three-dimensional boundary which is formed when two contrasting winds are converging. Then it is called as what? It is called as a frontogenesis. Okay, so it is called as a frontogenesis. Fine. So what we have discussed is what? We discussed temperate cyclones. They occur generally in which latitude? They occur generally in 35 to 65 degree latitude. That you have to keep in mind. What are the conditions for formation of temperate cyclone? You require two contrasting wind. You require frontogenesis to occur, and there need to be which type of force? Coriolis force presence. That need to be there. Then after that we discussed there are two terms. One is frontogenesis, another is called as what? Frontolysis. Frontogenesis means what? Frontogenesis means what? Genesis means origin. So origin of front is called as what? Frontogenesis. And frontolysis is what? Dissipating, dying. So when the fronts are dying, it is called as what? It is called as a frontolysis process. So what is a front? How do you define the term? It is three-dimensional boundary which is formed when two contrasting winds are converging. When two contrasting winds are converging. Clear? So for front to form, for frontogenesis to occur, the first condition is what? There need to be temperature contrast. There need to be temperature contrast. So temperature contrast means what? One should be warm wind and another should be what? Cold wind. Contrasting wind means what? One should be warm wind, another should be cold wind. So one thing you require is what? One thing that you require is a temperature contrast. You requires a warm wind and you requires a cold wind. Fine. Warm and cold, these air mass you require. So for the front to form, front to originate, you require the temperature contrast. The second thing that you require is convergence. Convergence of air masses. Convergence of air masses. This warm and cold air mass need to meet together. They need to converge together. That need to be there for frontogenesis to occur. That need to be there for frontogenesis to occur. Fine. The third thing is, okay, you are requiring a vertical motion. Okay, for third thing that you require is a vertical motion. Vertical motion. Vertical motion means what? One wind should rise up, another wind need to be sinking down. You require vertical motion. One wind need to rise up, another wind need to sink down. That is called as a vertical motions. Fine. Fine. And the last thing that you require is, because of this vertical motion, what is going to be formed? Cloud formation. What is going to happen? Cloud formation is going to happen. So these four phenomena are the characteristic of whom? Are the characteristic of frontogenesis. Are the characteristic of frontogenesis. These four phenomena are the characteristic of frontogenesis. Clear? So temperature contrast need to be there, convergence of air masses need to be there, vertical motion of the air need to happen, one wind need to rise up, another wind need to sink down, and the fourth is what? Fourth is cloud formation. Fine. So those are the important aspects that you have to keep in mind with regard to frontogenesis. Next, okay, that you keep in mind is a frontolysis. Next term, that is frontolysis. Frontolysis means what? What we have written, frontolysis, that the front are dying out, dissipating. So when the front will die out, when opposite conditions are going to be there. When opposite of this is going to happen, then what will happen? Front will die off. So one condition is weakening of temperature contrast. Weakening of temperature contrast. So the warm and cold mass, air mass temperature difference is minimizing. When their temperature difference minimizes, it is going to call as a weakening of temperature contrast. Clear? So when temperature contrast is more, front will form. When temperature contrast decreases, what will happen? The front is going to dissipate. Here what is happening? Convergence of air masses is happening. So for frontolysis, what will happen? Divergence of air mass. So for frontolysis to occur, divergence of air mass. Warm and cold air mass need to diverge. They need to diverge. They need not, okay, converge together. Clear? The third thing, here vertical motion is happening. As we discussed, winds are rising or winds are sinking. Here what will happen? Mixing will happen. Mixing will happen. Rather than vertical motion, you'll see mixing. Horizontal mixing will happen. So that is why mixing will happen in case of nothing but, okay, frontolysis process. Fine.
When divergence is taking place, how will it mix?
What?
The air is diverging, and how the mixing process.
See, when the air is, okay, what? When the air is diverging, clear? So what will happen is, okay, this is a air mass, okay, not a single this thing, clear? So what will happen is, okay, when air mass will move apart from each other, what will happen is, okay, you'll see the warm air mass, let's say it is moving like this. Already what is present over here? Cold air mass can be present. So warm and air mass, cold air mass are mixing. Clear? Here when cold air mass is moving this side, what will happen? What present here? Warm air mass. So they are mixing together. So that is mixing is happening in the case of this particular process. Fine. So there should be weakening of temperature contrast. There should be what? There should be nothing but okay divergence of air masses. There should be nothing but okay mixing. Clear? And if these things are going to happen, what will happen? Clouds will not be formed. So we'll write disappearance of cloud. Disappearance of cloud. Cloud will not be formed. Clear? So these are okay. What? These are the two terms you have to keep in mind. One is frontogenesis, another is what? Frontolysis. Fine. In examination, you may get a question like this that discuss what? Discuss the frontogenesis and frontolysis process. Frontolysis process and explain their characteristic. Explain their characteristic. Fine. So you'll get this type of question in the case of examination. Explain the frontogenesis process or frontolysis process and their characteristic. So you have to write about okay the frontogenesis means what? Formation of front. Frontolysis means what? The dissipation or dying of the front. Characteristic is what? What is the characteristic? Yeah, characteristic is these part we have listed down, that is temperature contrast, convergence of air masses, vertical motion, as well as okay what? Cloud formation. This is the characteristic of frontogenesis. What is the characteristic of frontolysis? Weakening of temperature contrast, divergence of air masses, mixing. These points you need to explain in case of your answers. Fine. Fine. So we discussed that how the temperate cyclones are being formed. Temperate cyclones are going to be formed when there is a two contrasting wind coming, and these two contrasting winds are forming what? Frontogenesis. Okay, fronts are being formed, and there need to be presence of which force? There need to be presence of Coriolis force. Okay, so how the fronts are being formed? What are the types of front that you have? There are different types of fronts. There are different type of fronts that are being formed. These are referred as a stationary front, warm front, cold front, occluded front, Fine. So these are okay. What? These are the different type of fronts that you are forming. Okay, the stationary front, warm front, cold front, occluded front. These are the different type of fronts that you are finding. Clear? What is a stationary front means? Stationary front means when there is okay what? When there is a no vertical motion. When there is no vertical motion happening, and warm and cold air mass are separated. Then it is going to be called as what? Then it is going to be called as a stationary front. So what is a stationary front? Stationary front is when there is a no vertical motion and warm and cold air mass are separated from each other. Then it is going to be called as what? It is going to be called as a stationary fronts. Fine. Clear? So what you see is here, you'll find a front like this. So assume this is okay what? This is your warm air mass, and assume this is your cold air mass. So this becomes your what? This becomes your which front? This becomes your stationary front. So you see vertical motion is not happening. Warm wind is not rising, cold wind is not subsiding. What you see is okay, warm and cold air mass are something that are separated. So when this type of situation is happening, then it is going to be called as what? it is going to be called as a which front? Stationary front. Okay, clear? So we say that wind motion on both side happens parallel to the front, happens parallel to the front, happens parallel to the front. So here you see the cold air mass is moving parallel, warm air mass is also moving parallel to the front. So here we are saying that wind motion on both sides happens parallel to the front. Fine. Fine. So you have a warm air mass, you have nothing but okay cold air mass. These warm and cold air mass are separated by whom? Separated by a front. This is okay what? There's no vertical motion happening along this particular front, rather winds are moving parallel to these fronts. Then it is called as which type of okay front? It is called as a stationary front. Now suppose if this situation happens, then what will happen? So this is your what? This is your front, stationary front. This is your cold air mass, and this is nothing but okay your warm air mass. Fine. So either warm air mass can be below, cold air mass can be above, or warm air mass can be above, cold air mass can be below. That is okay there. So if this situation is going to be there, then what will happen? What is happening? You are seeing it is which phenomena? Temperature inversion phenomena. Okay, so as you are going up, what is happening? Temperature is increasing, temperature inversion phenomena can happen. And you know that warm air will what? Warm air is what? Expand, it will rise up. So when it will expand, it will rise up. What will happen? When warm air will expand, it will rise up. What will happen? It can create a rainfall. It can create a rainfall. So that's why sometimes you can see the cloud that are formed on the stationary front can be cumulonimbus clouds. The cloud that are formed on the stationary front can be which type of cloud? Cumulonimbus cloud. And these cumulonimbus cloud can create which type of rainfall? Intense rainfall. Clear? Remember we discussed vertical clouds are known as which type of cloud? Cumulonimbus cloud. So because of the warm air rising, when warm air will rise up, what will happen? What will happen? Vertical clouds are going to be formed. Vertical clouds means which type of cloud? Cumulonimbus cloud. And this cumulonimbus cloud can create which type of rainfall? Intense rainfall. Short duration intense rainfall can happen. Fine. So this is okay how you see the front formation start. Formation start due to formation of which one? Front formation start due to formation of stationary front. Stationary front means the warm air mass and cold air mass will be separated by a by a front, and this warm and cold air mass are going to what? This warm and cold air mass are moving parallel to what? Parallel to the fronts. And if warm air mass is above, then which type of clouds can be formed? Cumulonimbus type of clouds can be formed. And this can create which type of rainfall? Intense rainfall. Fine. Next, the second that you see is okay what? The second that you see is creation of different fronts. Fine. Now, you know that cold air is which type of air? Dense air. Cold is which type of air? Dense air. Warm air is which type of air? Less dense air, because warm air expands. So expands means what? Less dense. Cold air is what? More dense. So you know that cold air is going to what? Sink down. Clear? It is more dense, so it will come down. And warm air is less dense, so it will what? It will nothing but okay rise up. So because of this, you see front will starts to appear like this. Okay, front will starts to appear like this, with cold coming down and warm starting to nothing but okay rise up, giving rise to what? Giving rise to nothing but okay two region. One, okay, this region, from where one region this where cold wind are subsiding, and one region is this where warm wind are nothing but okay rising. That is okay there. Clear? So this is called as what? This is called as a beginning of, this stage is called as a beginning of formation. Beginning of formation of cold and warm front. So beginning of formation of cold and warm front. Clear? So you'll see second stage where what is happening is cold wind will start to subside and warm will starts to nothing but okay rise up. So this is called as a beginning of formation of front formation. Fine. Now after this, what will happen is what? After this, you will see much more intense. Fine. So you'll find here what? You'll find here warm air mass, and this front is called as a warm front. And here you'll find what? Cold air mass, and this front is going to be called as a cold front. So warm front is where you see gradual slopes are there, while the cold front is where steep slopes are there. Steep slopes formation. So warm front, you are going to see gradual slope formation. Cold front, you are going to see steep slope formations. Clear? So what is cold front? How do you define this term cold front? Cold front is defined as when cold air mass advances into warm air mass, into warm air mass and start replacing it, then it is referred as cold front. Then it is referred as cold front. When cold air mass advances into warm air mass and start replacing it, then it is going to be called as what? It is going to be called as a cold front. Fine. Any doubt? Now, what type of clouds are going to be formed? What type of clouds are going to be formed? You know that when rainfall is happening, when air need to rise up. When air is falling down, then what will happen to rainfall? When air is falling down, then what will happen to rainfall? There will be no rainfall. When the rain happens, when air goes up, as you go up, what will happen to temperature? Declines. So what will happen? What will form? Cloud will form, and you'll see what? You'll see nothing but rainfall will happen. So when rainfall generally happens? When air going up. When air going up, then temperature is declining, then cloud is formed, and then rainfall is happening. What is happening over here? Whether air is rising or whether air is sinking? Air is sinking. So when air will sink, then what will happen? Whether rainfall is going to happen or rainfall is not going to happen? It is not going to happen, because which air is causing rainfall? Rising air is causing rainfall, not falling air. Sinking air is not causing rainfall. So what you see is, that's why along this front, in the cold front, you'll see a narrow band of clouds are going to be formed with little precipitation. Narrow bands of clouds are going to be formed with little precipitation. That will happen along what? That will happen along cold front. Okay, so along cold front, what will form? A narrow band of clouds are going to be formed with little amount of precipitation that you'll find along the cold front. Clear? So you may see appearing of which type of cloud? You may see appearing of cirrus cloud. You may see appearing of altocumulus cloud also, and sometimes nimbus cloud also, because little precipitation we are talking about. So you may see these cloud formations: cirrus cloud, altocumulus cloud, and nimbus cloud formation along which front? Along the cold front. Fine. Fine. And when warm front is going to be formed? When warm air is what? Being uplifted. From where the warm air is being uplifted, there you'll see formation of what? There you see formation of warm front. So where warm front is being formed? Warm front is being formed over here. So when warm air advances and rises up along a gradual slope, then it is referred as warm front. Clear? So from here you see warm air mass is something that is rising. From here you see warm air mass is rising. So when warm air mass advances and rises up along which type of slope? Gradual slope. Then such type of fronts are going to be called as a warm front. Clear? Now, since the warm air mass is rising, what will happen? Rainfall will happen, but you don't see formation of which type of cloud? Vertical cloud. Okay, you don't see formation of which type of cloud? Vertical cloud. Why? Because it is rising along a gradual slope. Okay, it is rising along the gradual slope. So you can see the cloud along warm front cloud along warm front will cause rainfall, but there will be absence of vertical cloud. So we discussed which cloud causes rainfall. Yes, rising air is causing rainfall. Which cloud causes rainfall? Nimbus cloud. We discussed which type of cloud is causing. Nimbus clouds are called as a dark dense cloud. And we discussed nimbus clouds are of two types. What are the two types of nimbus? One is cumulonimbus, another is two type of nimbus cloud we have discussed. One is cumulonimbus, another is nimbostratus. So two type of clouds we have discussed, cumulonimbus and nimbostratus. What is the difference between cumulonimbus and nimbostratus cloud? What is the difference between cumulonimbus and nimbostratus cloud? The cumulonimbus is which type of cloud? Vertical cloud. While nimbostratus is which type of cloud? Horizontal cloud. So we discussed just now cloud burst. When we discussed cloud burst in Uttarkashi, just now Uttarakhand. So we discussed which type of clouds were formed over there? Cumulonimbus. So this cumulonimbus creates what? This cumulonimbus creates a more rainfall in a localized region, while the nimbostratus create what? Wide rainfall in a much bigger region, that is okay there, because it is horizontal cloud. It creates rainfall in a wide area, but cumulonimbus creates rainfall in what? In a small area, because it is a vertical type of cloud. So all rainfall happens within a small area, like you saw cloudburst in Uttarkashi where it has happened. Clear? So here which type of clouds are being formed? Vertical clouds are not being formed. So which type of clouds are going to be there? Nimbostratus type of clouds are going to be formed. So along this, horizontal clouds are going to develop. Along this front, which type of clouds are going to be developed? Horizontal clouds are going to be developed. Clear? So remember tropical cyclone, and we discussed tropical cyclone, which type of clouds are being formed? Tropical cyclone, which type of clouds are being formed in tropical cyclone? Cumulonimbus. Yes, okay. In tropical cyclone, which type of clouds are being formed? Cumulonimbus. Clear? So if question comes, which is okay, what? Which is creating more rainfall? The tropical cyclone or temperate cyclone? Tropical will create more rainfall. More intense rainfall will be created by tropical cyclone, but these rainfall will be what? Localized in region. That's why we discuss whenever tropical cyclone hits India, coastal areas are only impacted, interior areas are not impacted. But this can, the temperate cyclone can create rainfall in a very wide area. Okay, it can cause not only on the coast but even in the interior region, that is okay there. Clear? It can cause rainfall in a very wide area, that is okay there. Clear? So this you remember it. Which type of generally clouds are being formed? Nimbostratus type of the clouds are going to be formed. There will be no vertical cloud. There will be absence of vertical cloud. Why the absence of vertical cloud? Why absence of vertical cloud? Because warm winds are rising like this on a gradual slope. Okay, they are not rising vertically, they are rising along, okay, which type of slope? A vertical slope. So cold front is what? Cold front is a steep slope. It is a very steep slope. Warm front is what? A gradual slope. Okay, that is okay there. Clear? So this is how the formation of fronts happen. So initially we discussed cold air mass and warm air mass is going to be there, separated by which type of front? Stationary front. Then as we discussed, cold air mass is which type of air mass? Heavy air mass. So what will happen? They will start to sink down, and the warm air mass is a less dense, so they will start to rise up. As a result, what will happen? Beginning of formation of what? Cold and warm front is going to be there. Then when the cold air mass starts to sink down quickly and warm air mass starts to, okay, rise up quickly, then you see formation of which two front? Cold front and warm front. You will see formation of cold front and warm front. So cold front will see little precipitation. You will see generally which type of cloud? Cirrus cloud, altocumulus cloud, sometimes nimbus cloud, that is okay there. And warm front is going to give get which type of rainfall? They are going to get wide rainfall, not localized rainfall. And which type of clouds are going to be generally formed? Nimbostratus type of clouds are generally going to form through the warm front. Clear? Any doubt regarding this one? So after this, what will happen? After this, what will happen? After this, you'll see warm air mass, okay, will rise up, and cold air mass will what? Sinks down. So again, what will happen? Again, you'll see like this front. So when most of the warm air mass is uplifted and most of the cold air mass has come down, so what will happen? This front will start to nothing but shrinks down. Clear? This front will start to shrink down because not much of warm air mass is left. So here more warm air mass is available. So this more air mass, warm air mass is rising up while cold air mass is something that is sinking down. So with cold air mass more coming, what will happen? There will not be much of warm air mass left. When there will not be much of warm air mass left, this type of front you are going to see. Clear? So this indicate a very little amount of what? Little amount of warm air mass left. Little amount of warm air mass is left to rise up. While most of cold air mass are sinking down. So this type of front are referred as what? This type of front is referred as occluded front. So this type of front is called as which type of front? Occluded front. Clear? This is the beginning of what? This is beginning of frontolysis. This is the beginning of what? Frontolysis. Means the fronts are dissipating. Fronts are dying. Beginning of frontolysis started now because the warm front and cold front is now shrinking down. That is called as a beginning of frontolysis. Fine. Lastly, what will happen? You will see the warm air mass is what? Completely uplifted by whom? By the cold air mass. Warm air mass is completely uplifted by the cold air mass. So cold air mass will be at the bottom. Warm air mass will be at the top. So at the occluded front, which type of weather or clouds you are going to see? You will see various types of cloud may appear. Like cirrus cloud, nimbus clouds. You may see various type of clouds may appear in the occluded front. Cirrus cloud can appear, nimbus cloud can appear, and finally what will happen? You will see this type of this type of stage. Now this is where the front are front have ended. Okay, so this process is referred as what? This process is referred as a frontolysis process. Fine. So what we have discussed is temperate cyclones are formed due to what? Temperate cyclones are formed due to convergence of two air masses. Then what will happen? There need to be front that need to be created. Frontogenesis need to happen. And the third we have written is a presence of Coriolis force. Then we discuss what is frontogenesis and what is frontolysis. Frontogenesis is formation of front and frontolysis is what? Dissipation of front. Okay, that is okay there. Frontolysis will occur when winds are what? Diverging. Winds are the temperature gradient becomes wind are what? Becoming less. And you'll see what? You'll see mixing of winds are happening. Then frontolysis will occur. The frontogenesis will form when there will what? More temperature gradient, more clouds are going to be formed, and you'll see also more convergence of wind rather than divergence of wind. Then frontogenesis occur. These are different type of fronts that are being created. So we discuss first front is which type of front? Stationary front. So stationary front means the warm and cold air mass are separated by a simple front. They are moving parallel to what? They are moving parallel to this front, which is called as a stationary front. After this, what will happen? You'll see the beginning of front formation will start, and you'll see the warm air mass will rise up, cold air mass will starts to sink down. Then when more cold air mass is sinking down, more warm air mass is rising up, then you'll see formation of which front? Warm front and cold front. That is okay there. Cold front, you'll see narrow band of cloud with little precipitation. Warm front, you'll see the rainfall will happen. but rainfall is going to be gentle in nature because nimbostratus type of clouds are being formed, not cumulonimbus type of clouds are being formed. And the lastly that you see is what? When all the warm air mass are what? When all the warm air mass are uplifted and no much warm air mass is left, then you will see formation of which type of front? Occluded front. And finally, you will see the cold air mass will be at the bottom and warm air mass is uplifted. So again, you'll see come back at which front? Stationary front. So this process of dissipating of front is referred as what? Dissipating of front is referred as a frontolysis process. Clear? So this is all about formation of what? Formation of fronts. Fine. Now, what happens in case of what? What happens in case of temperate cyclone? What happens in case of temperate cyclone? So we discussed temperate cyclone occurs where? Yeah, it occurs between 35 to 65 degree latitude. Now, take this as Earth. This is your equator region. This is your what? Tropic of Cancer. This is your what? So this is where you'll see formation of which belt? Subtropical high pressure belt. Here you'll see formation of which pressure? Subpolar low pressure belt. Here you see formation of which pressure? Polar high pressure belt. From here to here, which wind flows? From here to here, which wind flows? Westerlies. Westerlies. From here to here, which wind comes? From here to here, which wind comes? Easterlies. Clear? Easterlies are coming from which region? Easterlies are coming from which region? Polar region. So easterlies are coming from the polar region. So what will happen? It is going to be warm wind, cold wind. Cold wind. Westerlies are coming from where? From the tropics region. When tropics region, it is going to be warm wind or cold wind? Warm wind. So now you are seeing two contrasting wind coming together. Warm wind, westerlies, and cold wind, easterlies. When these will come together, what will happen? What will happen? Front formation will happen. So this front formation happens in 35 to 65 degree latitude. So that's why temperate cyclones occurs in this particular region. Fine. Any doubt regarding this part? Now, how this cyclones can form? So if you remember, we'll just also write regarding tropical cyclones so that you have a differentiation also. We discussed where the tropical cyclone originate. 10 to 30 degree, yes. And where the temperate cyclone is originating? This is a latitudinal difference. Fine. What is where the tropical cyclone originate? On the land or on the oceans? On the oceans, yes. So tropical cyclone only originates where? Only originate on the ocean, because we discussed what is condition for the tropical cyclone to occur? Coriolis force, yes. And what is the condition for tropical cyclone to occur? You require warm sea surface. We discussed one thing that you require is warm sea surface. The temperature should be greater than how much? 27 degrees Celsius. Okay, so that's why tropical cyclone only occurs where? Only occurs at the ocean. Remember, we discussed it develops in what? It develops in Bay of Bengal and then move towards what? Move towards something, but okay, this particular part that is okay there. And it always forms on which side? It always forms on which side? On the eastern side. Why it forms on the eastern side? We discussed which type of current blows over here? Warm oceanic current. Okay, so that's why tropical cyclone always originate over the ocean, but temperate cyclone can originate where? Temperate cyclone can originate where? Both on the ocean and the land, because this mixing of wind can, okay, what? Wind can converge where? On the land also, wind can converge where? On the oceans also. Clear? Wind can blows over the land also, wind can blows over the oceans also. So you can see some, okay, what? This is where you'll find what? China, Central Asian countries and other countries. Here you'll find what? Atlantic oceans also, that is okay there. So you'll find the convergence of wind can happen on the land also. Convergence of the wind can happen on the ocean also. That's why temperate cyclone can originate either on the land or on the oceans. Clear? They can originate on both things. Fine. So that's why remember that since westerlies and easterlies are meeting both on land and the oceans, So that's why temperate cyclones can originate in both these regions. Clear? The third thing, we discussed what is the structure of tropical cyclone. What was the structure of tropical cyclone we have discussed? Eye region, eye wall region, and spiral band or rain band region. Yes, eye wall and spiral band and rain band region. Clear? So it is giving you which type of shape? Okay, it is giving you which type of shape? Mushroom shape. Okay, so you see this is okay how the eye region is there, surrounding eye region, which region is there? Eye wall, and you see these are the spiral band region, rain band region, that is okay there. How do you see that the structure of temperate cyclone? How do you see structure of temperate cyclone? As we discussed, temperate cyclones are formed due to fronts. So how do you see structure of temperate cyclone? It is which shape? It is which shape? So you have what you have like this. This is called as V shape. When you inverse it, it is going to be called as what? Inverted V shape. It is going to be called as which shape? Inverted V shape. Clear? So what is the difference that you are finding between tropical cyclone and a temperate cyclone? Tropical cyclone generally have which type of shape? Mushroom, and you will have structure eye wall and spiral band region. Spiral band region. While this temperate cyclones have which type of shape? Inverted V shape. Inverted V shape. And you will have which type of different you have which type of warm front, cold front. You have warm front, cold front. All these fronts are going to be present in the structure. Fine. Another difference. So tropical cyclone is not having the concept of front. It is absence of front is there in the tropical cyclone. In temperate cyclone, what will happen? Presence of fronts are going to be there. Presence of fronts are going to be there. Presence of fronts are going to be there. Fine. Now, tropical cyclones, how it is formed? Tropical cyclone, how it is formed? We discussed it is formed on the eastern side, and they move towards where? They move from where to where? From east to west. So tropical cyclone moves from where to where? From east towards nothing but west. Tropical cyclone moves from where to where? From east towards west. Temperate cyclone, how it moves? Temperate cyclones, how it moves? It moves from west towards east. Okay, so westerlies. Westerlies are warm air mass. Which is warm air mass? Westerlies are warm air mass. Westerlies are blowing from where? From the west direction. So that's why these cyclones move from where to where? These cyclone moves from west towards nothing but east region. They are moving from west towards nothing but east region. This is how you see movement of what? Movement of nothing but the temperate cyclone. So tropical cyclone moves from where to where? From east to west region. Temperate cyclone moves from where to where? From west to east region. Fine. When tropical cyclone generally occurs? We discuss in late summer. Yes, okay. We discuss tropical cyclone generally occurs when? In late summer. When you will see temperate cyclone will more occur? When you see temperate cyclone going to be more occurring? July. Anyone else? We discussed for temperate cyclone to occur, front need to be formed, and front is going to be formed when? What is condition for frontogenesis? What is condition for frontogenesis? Temperature contrast need to be more. Clear? Because winds are converging throughout the year. These are permanent pressure belt, and we discuss convergence of wind will happen throughout the year. So temperature, when there is a more temperature contrast, then only what will happen? You will see what? You will see more cyclones are going to occur. So when do you see more temperature contrast? When do you see more temperature contrast? Summer and winter. Anyone else? Anyone else? When do you see more temperature contrast? Now, in summer, sun position is going to be, let's say, northern hemisphere we are talking about. In summer, sun position is going to be where? Not going to be that much cold. Okay, that is okay there. Clear? But when winter conditions are there, when sun position shift to Tropic of Capricorn, what will happen to poles? The 6 month of night they are going to experience. When 6 month of night, then what will happen? Easterlies becomes what? Too cold. So that's why you see when temperature contrast is going to be more, when temperature contrasts are going to be more, they are going to be generally more in the winter season. They are going to be more when? They are going to be more in a winter season, that is okay there, because easterlies become too cold in winter while westerlies remain warmer, that is okay there. So this temperature contrast is more in case of nothing but okay winter. That's why most temperate cyclones occurs during what? During the winter season or early spring season. Early spring, after winter, when early spring comes, then you see more amount of what? More amount of temperate cyclone occur. Okay, clear? So tropical cyclone more occurs during what? Don't more occur during late summer month. The temperate cyclone more occurs during winter or early spring. After winter, when spring comes, then also you see the easterlies are cold. So that's why you see temperature contrast is much more over there. So winter and early spring is when you see more amount of what? More amount of temperate cyclones to occur. Clear? Now remember we discussed cyclone moves how, in which clockwise or anti-clockwise manner? Anti-clockwise in which hemisphere? Northern hemisphere. Which type of movement of cyclones are there? In tropical cyclone, what we have written? How the cyclone moves in northern hemisphere, how the cyclone moves in the southern hemisphere.
In northern, anti-clockwise.
Yeah, in northern it is going to be anti-clockwise. In southern we have written as what? Clockwise. Why? Because we discussed this is a low pressure. What happens is what? The wind should ideally come from high pressure towards what? Low pressure. This is high pressure region. Wind should ideally come, but we discussed because of Coriolis force in northern hemisphere, wind are deflected towards where? Because of Coriolis force in the northern hemisphere, wind are deflected towards where? Wind are deflected towards right hand side. Wind are deflected towards which side? Right hand side. In what? Right hand side in the northern hemisphere. Clear? Due to Coriolis force, deflection happens in the wind and wind are deflected towards which side? Right hand side. So this is forming which type of okay rotation? That is forming the anti-clockwise rotation. So that's why this in the okay what? In the northern hemisphere, winds are okay moving in what? Anti-clockwise direction. In southern hemisphere, what will happen? Let's say this is a low pressure zone. In southern hemisphere, what will happen? We discuss winds are deflected towards what? Left hand side. When left hand side, so they are going to be which type of rotation? Clockwise rotation. Clear? So remember that both tropical and temperate cyclone, both tropical cyclone and temperate cyclone moves anti-clockwise in northern hemisphere and clockwise in which hemisphere? Southern hemisphere. Clockwise in southern hemisphere. Both tropical and temperate cyclone moves anti-clockwise in which hemisphere? Northern hemisphere, and clockwise in which hemisphere? Southern hemisphere. Clear? But the path is different. Remember the path. Clear? Tropical cyclone moves from where to where? From east towards west. The temperate zone moves from where to where? From west towards east. Path is different, but the rotation, the movement is what? Anti-clockwise in a northern hemisphere and clockwise in which hemisphere? Southern hemisphere. Fine. Any doubt regarding this particular thing? So this is what happens in case of nothing but okay what? This is what happens in the case of the temperate cyclones. Fine. So how temperate cyclones are formed? When two winds are going to converge. When two winds are going to converge, what will happen? Two contrasting wind. What will be formed? Warm front will form and cold front will form. On the warm front, what will happen? More amount of rainfall. On the cold front, what will happen? Narrow band of precipitation is going to be there. So that's why you'll see more type of rainfall happens in case of what? In case of the temperate cyclones. Clear? So generally, as we discussed, tropical cyclone, when occurs, you may see a rainfall of 3 to 4 days, sometimes extending up to a week. In temperate cyclone, you may see a rainfall of around 20 days, even 15 days of rainfall. And these rainfall is not localized in a coastal areas. These rainfall can happen in what? Wider areas. As we discussed, wind can converge in both land also and sea also. So that's why you can see rainfall can happen in a much wider area in case of temperate cyclone. Clear? So if you are getting a question, differentiate between tropical cyclone and temperate cyclone. On these lines, you need to differentiate between whom? On these lines, you need to differentiate between tropical and temperate cyclone. You can also add one that tropical cyclone lasts for around a week. It can last for around 2 to 3 weeks. Tropical cyclones are basically what? Basically causing rainfall in a localized area. Intense rainfall happens. The temperate cyclone can cause rainfall in much wider area, but less intense rainfall happens. So this is okay. Another point of difference is that you can keep in mind between tropical cyclone and temperate cyclone. Fine. So tropical cyclone, much greater rainfall. The temperate cyclone, much lesser rainfall. But temperate cyclone create rainfall in a wide area. Tropical cyclone create a rainfall in a localized area. Fine.
In the tropical rainfall, the rainfall will be intense, but considering the volume of rainfall, more in temperate.
It will considering the volume of rainfall, it will be more in temperate. Not necessarily considering the volume of rainfall will be more in temperate. As we discussed, more rainfall happening in a localized area, then what will happen? Volume can be more in what? Rainfall volume can be more in what? Can be more in that area, no? As compared to temperate, what will happen? Since temperate are creating in wider area, you are saying that rainfall will be more in temperate as compared to nothing but tropical. But tropical can produce very heavy rainfall in a very localized area. So it can cause it can cause flooding and other thing in a localized area. But temperate can cause flooding in a wider areas. Clear? It can cause flooding in a wider areas because rainfall is happening for 2 to 3 weeks. Okay, so it can cause flooding in a wider area. That is okay there. Clear? So flooding will be more intense in a tropical cyclone. It will be less intense in what? Temperate cyclone. Fine. Any doubt regarding this particular thing? So sometimes, you see, what is the extension of India? We have written. What is the extension of India? So we discuss India extend from 8 degree north to almost 37 degree. India is extending from where to where? From 8 degree north to almost 37 degree. So sometimes you see temperate cyclone generally create rainfall in India when? Temperate cyclone generally create rainfall in India in which season? Winter season. Sometimes you may see, because we discussed when temperate cyclones are more occurring. In the winter they are more occurring. So you might see some intense rainfall in case of nothing but winter season in India, and these are referred as what? These are referred as a western disturbances. In India, these are referred as which type of disturbances? Western disturbances. Okay, in India, these are referred as which type of disturbances? Western disturbances. So sometimes you may see you may see rainfall in India because of what? Because of temperate cyclones, and these are referred as which type of disturbances? Western disturbances. Generally in Punjab, generally in Haryana region, sometimes in Delhi, you might see experiences of these rainfall. Clear? Yeah. Clear? So we discussed one more thing that you can keep in mind is tropical cyclone, where it is originating at the ocean. We discussed why it is originating at the ocean, because what is the condition we have written, that it requires a warm sea surface. It requires a warm sea surface. That's why we say tropical cyclones are what? Thermal in origin. They are thermal in origin. Why thermal in origin? Because it requires a warm sea surface, while temperate cyclones are dynamic in origin. Dynamic in origin means it requires two contrasting wind to come. Clear? So that difference also you can keep in mind. The tropical cyclones are thermal in origin, while temperate cyclones are something that are dynamic in origin. Clear? Clear? Sometimes as we discuss how the tropical cyclones are being formed, this is how the structure of tropical cyclone we have listed down. So sometimes we call it as a mushroom shape. In some books you might also see this as which type of shape? Written as elliptic shape. You can find this also written as a elliptical shape. You know that ellipse is like this, elliptical shape. Okay, so this is in which shape? This is an elliptical shape. Okay, that is okay there. So sometimes in some books you also might find elliptical, so just don't get confused. It can also be called as a elliptical shape also. Fine. Now just see this particular map. Now this is a map that you are finding. Now this is where your Tropic of Cancer are there. This is where Tropic of Capricorn are there. Clear? During winter what will happen? We discuss sun position will what? Shift over here. December 22nd we discuss winter solstice. Sun position is going to be here. When we discuss sun position is here, what will happen to equatorial low pressure belt? What will happen to equatorial low pressure belt? We discuss it will shift to the southward direction, because this region is okay receiving more amount of what? Sunlight. So equatorial low pressure belt will shift southward. What will happen to subtropical high pressure belt? Subtropical high pressure belt now will form over here. Remember subpolar low pressure belt? We discuss it will now form over here. Subpolar low pressure belt, polar high pressure belt. This is how the polar high pressure belts are going to be formed. Clear? So we discussed these will shift southward because of what? Because of sun position. This is what we discussed regarding shifting of pressure belt. So we discussed equatorial low pressure belt is a meeting point of which two wind? We discussed southeast trade wind and northeast trade wind. We discussed when northeast trade wind will cross the equator, then what will happen? Yeah, they will be deflected, becomes a northwest wind, and this northwest wind causes rainfall where? We discuss in Australia and etc. So remember seasonal wind we have discussed, northwest wind and southwest monsoonal wind. That is okay there. Clear? Now here to here which wind flow? From subtropical high pressure belt to subpolar low pressure belt, which wind flow? Which wind flow from here to here? Westerlies. Westerlies. Clear? So westerlies will move like this. Westerlies are moving like this. Clear? Westerlies are moving like this. So when westerlies are moving over Mediterranean region, what will happen? This is a Mediterranean region. When westerlies are going to move over Mediterranean region, what will happen? They are going to pick up what? Moisture. Because as we discussed, if they are moving, winds are moving over sea region, then what will happen? They'll pick up the moisture. And when they are picking up the moisture and coming towards the land side, what will happen? Rainfall will happen. So that's why you see this region is where rainfall is something that is okay happening. It is this rainfall is reaching till India. This rainfall is reaching till India in the winter season. Clear? This is referred as what? Western disturbances. This is referred as what? western disturbances. Clear? So when westerlies pick up the moisture from the Mediterranean Sea region, causes rainfall in these areas and reaches to the India. By the time it reaches to India, almost most of the moisture is lost, because it creates rainfall in Iran, it creates rainfall in case of Pakistan. By the time it reaches to India, most of the moisture are being lost. So only slight rainfall happens in Punjab, Haryana region, that is okay there. And this is called as what? This is referred as a western disturbances. This is referred as a western disturbances. So as we discussed, India's 90% of rainfall happens due to what? Southwest monsoonal wind. Some pre-monsoon shower happens in India due to conventional, this is in summer season, due to the convectional rainfall. We have discussed that pre-monsoon shower. And some rainfall happens in a winter. A minute rainfall happens in a winter due to which type of disturbances? Western disturbances. Okay, so this is okay. What? This is the rainfall in India. So entire, we discussed our rainy season is what? Rainy season is the July to September, when most of the rainfall happens due to southwest monsoonal wind. But some rainfall can happen in the summer month, that is May or April, due to pre-monsoon shower. We call it as a convectional current, because intense heating happens due to summer month. And some rainfall may happen in winter due to which type of disturbances? Western disturbances. Clear? Any doubt regarding this one? Now, when the let's say sun position shift from here to here, what will happen? That is equinoxes. We discuss on 21st March what will happen. On 21st March, what will happen? Sun will come back to the equator, equinoxes will occur. When equinoxes will occur, what will happen? When equinoxes will occur, what will happen? So then you see what? Sun come back to the normal. So what will happen to equatorial low pressure belt? It will come back to its original position. What will happen to subtropical high pressure belt? It will come back to its original position. Now westerlies are blowing like this. When westerlies are blowing like this, they are not coming and creating a rainfall in India. In the summer month, they are not going to come and create rainfall in India. That is okay there. Clear? So then, because subtropical high pressure belt shift upwards because of shifting of pressure belt, now the westerlies will not cause rainfall in India. So no rainfall by the westerlies in the summer month or in spring season or in autumn season. Why? Because the westerlies are okay blowing up above India, that is okay there. But when shifting of pressure belt happen, winter season happens, subtropical high pressure belt shift lower, and as a result you see westerlies causing rainfall in India. So that's why these are referred as which type of disturbances? Western disturbances. Fine. Any doubt regarding this particular thing? Anyone having any doubt? So if you get at this type of question, Which is correct statement? Second is correct. One is also correct. Fine.
Second is
First is also correct. Fine. So just now discussed, in summer, westerlies do not blow over India because pressure belt shift upward. So that's why westerlies do not blow over India. So second is correct. Now, which type of wind creates a rainfall? Offshore wind or onshore wind? Onshore wind. Okay. What is onshore wind? That comes from sea to land is called as what? Onshore, and that moves from where to where? Land to sea is called as a offshore. So westerlies are going to be which type of wind? Onshore wind. Okay, so this is okay, wrong statement. Westerlies has to be onshore, then only it can create a rainfall. So when westerlies moves over what? Moves over the Mediterranean Sea, it pick up moisture and becomes which type of wind? Onshore wind. So as a result, okay, they create rainfall in what? India, which is referred as a western disturbances. Clear? Any doubt regarding this one? So this is all about what? This is all about the concept of temperate cyclone. So we discussed what is temperate cyclone. These cyclones are something that can originate over where? Now what the definition you can write? These are atmospheric disturbances. Atmospheric disturbances originated in 35 to 65 degree latitude. Originated in 35 to 65 degree latitude over land or ocean. Land or ocean, which causes the squall, storm surge and rainfall. Which causes squall, storm surge and rainfall. So this is the definition you can write with regard to temperate cyclone. These are atmospheric disturbances originated in 35 to 65 degree latitude. They can blow over what? They can blow over both land as well as oceans, and they can cause squall, storm surge and rainfall. We discussed what is squall. Remember squall? What is squall? Tropical cyclone. What definition we have written regarding tropical cyclone? What definition for tropical cyclone? There we have used the term squall. There we have used the term storm surge. What is squall? What is storm surge? Tropical cyclone definition. We have used the term squall. We have used the term storm surge. What is squall? What is storm surge? Anyone? What is squall and what is storm surge? What definition we have written? Anyone have noted down the definition?
violent originate on ocean to coastal area causes destruction.
Causes destruction and
Creates a condition like vertical windshield
no, this is not definition.
causes heavy rainfall, strong winds,
Yeah.
surges,
Causes heavy rainfall, storm surges and strong winds. Okay, so what is the term we have used? What is storm surge over there? What is a storm surge over there?
which causes floods.
Storm surge is very heavy wind, which, okay, what? which causes the oceanic water to enter into what? Coastal areas. Yes, okay. So it generates a wave. It is a wind that generates a wave which causes oceanic water to move into what? Oceanic water to move into the coastal areas, which is called as a storm surge. Clear? So when oceanic water moves into coastal areas, what will happen? Flooding can happen. Flooding can happen. Salinization can happen. So we have written that particular part, okay, with regard to what? With regard to storm surge. Clear? And what is squall we have written? Yeah, wind, very high velocity wind that is moving vertical, that is called as a squall. Clear? Fine.
What is possible?
Squall is very high velocity wind. Very high velocity wind. Very high velocity wind, which causes rainfall. Which causes rainfall. Rainfall and localized storm. Which causes rainfall and localized storm. Fine. Clear? Any doubt regarding this one? So this is all about your cyclones, tropical cyclones and temperate cyclone. So tropical cyclone, naming also we have discussed. Temperate cyclones, so the first thing you keep in mind, if temperate cyclone comes in the examination, explain temperate cyclone, then what you are going to write? First is definition, then what you're going to write? You have to write about frontogenesis and the conditions. What are the conditions we have listed down? Two contrasting wind, frontogenesis, as well as the presence of Coriolis force. So condition which will lead to formation of temperate cyclone. Then what is structure? You have to talk about which type of structure. Inverted V structure. Then you have to explain, okay, what? You have to explain the different type of fronts. That is stationary, yeah, cold, warm, and occluded front. So you have to explain these type of fronts. Then what will happen? Then you have to talk about the different type of fronts, distribution of temperate cyclones, and lastly their movement. So these are points you need to explain if question comes regarding temperate cyclone. Okay, so first definition, then what are the conditions, then what is the structure, make the diagram of warm front, cold front, occluded front, and etc. Distribution of temperate cyclone, as we discussed, where they are generally lying in which latitude, 35 to 65. So they are okay, they are causing rainfall in what? Rainfall in USA, in Canada, in case of okay European region, sometimes okay in winter in India, which is referred as a western disturbances. So you have to mention about those particular distribution of temperate cyclone. And lastly, movement. We discussed how they move anti-clockwise in northern hemisphere and clockwise, and what is their path? From west towards east. They move from west towards east. So that movement part you have to keep in mind. Clear? So this is all about your cyclones, and we are now done with all type of precipitation. Remember which type of precipitation we have discussed? Convectional rainfall. The second we have written is orographic type of rainfall. The third we have written is frontal rainfall, and the fourth we have written is what? Cyclonic rainfall. So we discussed two type of cyclonic rainfall happens: tropical cyclone and temperate cyclone. So now we are done with all form of precipitation. So condensation is over, precipitation is over, and evaporation is over. So now we are finished with water cycle. Clear? Have a break, and then we'll start with the El Nino phenomenon. So now we are taking up the El Nino. There is a three term Elnino, Lanina, and Enso. Enso is referred as a El Nino Southern Oscillation. It is referred as a El Nino Southern Oscillation. So there are three terms: El Nino, La Nina, and Enso. Enso is referred as a El Nino Southern Oscillation. What the term oscillation means? Yeah, moving from one end to another end. This is what you oscillation is something that is okay there. So like you see, pendulum oscillates from one position to another position. So it continuously changes its direction, and it continuously changes its direction when it is moving from one point to another point. Then from here to here, it changes its direction. So since here also the direction keeps on changing, that's why we call it as what? We call it as a southern oscillations. That's why we call it as a southern oscillation. So El Nino is considered as, it is considered as atmospheric ocean coupled phenomena. Atmospheric ocean coupled phenomena means it's not a single, it is combining the ocean phenomena and atmospheric phenomena. Both are something that are being combining to form El Nino. So El Nino is being described as what? Atmospheric ocean coupled phenomena. Fine. Till now we have discussed three types of cell. If you remember, one cell we have discussed is what? Yeah, Hadley cell. The second, Ferrel cell, and the third we have discussed is what? Polar cell. Yes. Okay. So we discussed between equatorial low pressure belt to subtropical high pressure belt. You have Hadley cell. From subtropical high pressure belt to subpolar low pressure belt, you have Ferrel cell. The third cell we have discussed is what? Between subpolar low pressure belt to polar high pressure belt, we have polar cell. Clear? So these are okay. What? These are the different type of cells till now we have discussed. Now we are coming to concept of what? We are coming concept of Walker circulations. That is fourth type of cell or Walker cell. This is a fourth type of cell that we need to study, Walker circulation or Walker cell. Fine. So what is this Walker cell or Walker circulation? When this circulation is only, this Walker circulation is reversed, constantly reversed. That's why it is called as what? It is called as an oscillation, southern oscillation. Clear? So what is this Walker circulation? Now, if you see, now when you see this region, normally which current flows in Peru region? Yeah, here which current is there? Peru current. It is written as which current? Peru current. So this Peru current flows where? In the coast of Southern America. Clear? Now this Peru current is which type of current? It is a cold current. Yes, the Peru current is cold current, and on the east, this side of Pacific Ocean, when you are coming, it is a cold current, and when you are coming onto this side of Pacific Ocean, you are forming East Australian current, and this East Australian current is okay. Which type of current? Warm current. It is which type of current? It is warm current. Fine. Now, because of because of this, the cold current, air that is in contact of this cold current will happen to this air that is in contact with the colder current, colder water, what will happen? It also becomes cold. Clear? When air becomes cold, what will happen? Which type of pressure are going to be developed? High pressure are going to be developed. Fine. Here, the water is warm in nature. When water is warm in nature, what will happen to air? Air becomes warm in nature. Air will expand. So which type of pressure here is going to be formed? Low pressures are going to be formed. Clear? This is happening in which ocean? Southern Pacific Ocean. So that's why it is we have used the term southern oscillation. No? Why southern oscillation we have used? Because it is happening where? It is happening in the Southern Ocean. That is there. Clear? So normally what you find is getting disappear here. So this part is your Southern America, while this part is where Australia is something that is there. So this part is your Australia. Now here you are finding what? Here you are finding is how the equator is something that is passing. Now which current is blowing over here? Just now discussed Peru current, which is a colder current. Which current blowing over here? The East Australian current, that is a warmer current. Clear? Because of this, what will happen? As we discussed, the high pressures are going to be formed over here. And what is being formed over here? Low pressures are going to be formed over here. Clear? Now, because of high pressure means what will happen to wind? Wind will sinks down. High pressure means compression will happen, wind will sinks down. And low pressure means what will happen to the wind? Low pressure means what will happen to the wind? It will expand. Okay, so you'll see wind expanding from here, wind rising from here, then moving in this direction, and then sinking where? Sinking in this particular region. And again, a wind blows from where to where? From high pressure to nothing but low pressure region. This circulation is called as what? This circulation is called as a Walker circulation. This circulation is referred as which type of circulation? Walker circulation, or also referred as a Walker cell. It is referred as a Walker circulation, or also referred as a Walker cell. Fine. So what you see is because of the colder oceanic current, here high pressure. Because of warmer oceanic current, here you find low pressure. From the low pressure, wind will rise up, move in this direction, falling in this particular region. From high pressure to low pressure, a wind will blow. That is there. This circulation is referred as a Walker circulation. Clear? Now, this is a normal situation. This is a normal situation which happens in case of Pacific Ocean. This is a normal situation case in the Pacific Ocean. Fine. Now, because of high pressure, what will happen? You don't see much of rainfall where? Because of high pressure, we discuss sinking wind do not create which rainfall. Which type of wind create rainfall? Rising wind create rainfall. So that's why here you'll experience more rainfall. Here you'll experience what? Lesser rainfall. So if you remember, which desert is over here? Andes is a mountain. Which desert is over here? Which desert we talked about? Atacama Desert. Yes, Atacama Desert is the desert that is lying in this region. And if you remember, Atacama Desert is which type of desert? It is the driest desert in the world. It is one of the driest deserts we have written with regard to Atacama Desert. So which desert you are finding? Atacama Desert. So normally this region receives very less rainfall. That's why you see Atacama Desert is which type of desert? Driest desert in the world. Fine. What will happen? Cold current. When cold current is coming, then what will happen? You see water will become cold. So here what will happen? Cold current is coming from the polar region. Water here will become cold. What will happen to the colder water? What will happen to the colder water? Colder water is what? Colder water is denser. So what will happen? It will sink down, and the warmer water from here will come up. Clear? So warmer water will come up and colder water will sinks down. So surface water is becoming cold in nature. This water is becoming cold in nature. That's why it is going down. And warmer water will come up from nothing but bottom of the ocean. So when warmer water is coming up, what will happen? It will bring lot of nutrients. It will bring lot of nutrients from bottom of the ocean to the surface. Bottom of oceans to the surface. Fine. So it will bring lot of nothing but nutrient from where to where? From the bottom of ocean to the surface. Okay, that is okay there. Clear? As a result, this is very good for whom? Fishes, marine organisms. Okay, so this is very good for fishes or marine organisms. Marine organisms. Because nutrient is coming onto the surface. Okay, so this is very good for fishes, marine organisms, even the phytoplanktons, because they are getting nothing but nutrient and etc. That is okay there. Clear? So what will happen is when cold current comes, it makes the surface water what? It makes the surface water cold. As a result, colder water sinks down and warmer water comes up. So warmer water comes up. Okay, along with that, what comes out? Nutrient also comes out onto the surface. As a result, this is very good for nothing but fishes, marine organism, phytoplanktons. Fine. We are not talking about Elnino and Lanina right now. Just normal situations we are talking about. When neither Elnino is occurring, neither Lanina is occurring. We are talking about normal situations. Fine. So what you find is when humans are not happy, because no rainfall is happening means humans are not happy. Then you will find what will happen to oceans? Oceanic organisms, they are very happy. Why? Because you see, nutrient are something that is coming up. So they are very happy. Clear? Any doubt regarding this particular thing? Here, where humans are happy, organisms are not happy because less nutrients are something that are there. Clear? Fine. So this is what? This is the normal situation that happens in case of what? Normal situation that happens in case of Pacific Ocean. And this is what? This is called as a Walker circulation. Clear? So here you see this is an oceanic phenomena. This oceanic phenomena is affecting the atmospheric phenomena. This oceanic phenomena is affecting what? Atmospheric phenomena. So this colder water is creating high pressure. This warmer water is creating what? Low pressure. So this oceanic phenomena is impacting what? Atmospheric phenomena. That's why we have written in Elnino that it is what? It is both oceanic and atmospheric coupled phenomena. That is okay there. Clear? Because the situation is what? This situation is nothing but interrelated over here. Fine. Now what happens in a El Nino situation? What happens in an El Nino situation? The condition get reversed. Now you'll find what? You'll find here the Southern America. You'll find here Australia. Clear? This is how you'll see the equator is something that is passing. Now here now you'll see warmer current, and here now you see colder current. Okay, so in El Nino situation, what happens is what happens is this current, which is a Peru current. Which current is there? Peru current, which is normally cold. Peru current is normally cold. It becomes which type of current? Warmer current. While the East Australian current, which is a warmer current, now becoming which type of current? Colder current. Clear? So East Australian current, which is nothing but warmer current, is now becoming which type of current? Colder current. That is there. Clear? As a result, here colder current means what? Air becomes cold. Air becomes cold means what will be formed? High pressure. Here water is warmer in nature. When water warmer in nature, what will happen to air? Air also becomes warm. When air also becomes warm, which type of pressure you are going to see? Low pressure. So now you see wind rising like this. Wind rising like this, moving in this direction, falling like this, and then moving in this direction like this. Clear? So this is a situation. Now this is what? Reverse of Walker circulation. This is what happening? Reversal of Walker circulation. Worker circulation is something that is reversed. Normally, worker circulation, we discuss here high pressure, here low pressure. So worker circulation is okay, reversing in case of El Nino. Clear? Why reversal happens? Because Peru current becomes warmer current, while East Australian current becomes which type of current? Colder current. Clear? Because of this, pressure changes. When pressure changes, worker circulation is reversed. Now, when this situation occurs, it is called as what? When this situation occurs, it is called as a El Nino situation. It is called as a El Nino situation. Fine. So in an El Nino event, the Peru current, which is normally a colder current, becomes which type of current? Warmer current. And as a result, worker circulation is something that is okay being reversed. Worker circulation is something that is okay being reversed. Fine.
So in the Peru condition copper cells, the colder the water is impact of the water will come up. So the surface water will be warmer in nature even though the current is cold.
Surface water is warmer in nature even though? No, it is not going to be warmer. Why it is not going to be warmer? Let's say colder is coming down, colder water is coming down, but okay, the cold current is also coming from where? From the polar region. So what will happen? Okay, warmer water which will come up also becomes what? Cold because of the colder current coming. Then again sinks down. Then again will okay, warmer water will come up. This circulation will continue to happen. Yeah. So what is El Nino? It is a phenomena which occurs when Peru current becomes warmer in nature, leading to reversal of which type of circulation? Walker circulation. Leading to reversal of which type of circulation? Walker circulation. Fine. Fine. Now, why the question here is why this Peru current becomes warmer current? We are saying Peru current is normally which type of current? Colder current. So why this Peru current is becoming warmer current? Why this change is happening?
One I can think of is because the current is coming from because of global warming.
Global warming. Yes. Any other thing? Any other thing? So why do you think this Peru current, which is a colder current, is becoming warmer current in nature?
Because changing temperature.
Change in temperature. How? Climate. Okay, like climate change. Any other thing? Any other thing that you can think of? As we discussed, okay, this entire Pacific region is considered as which zone? Ring of fire. Ring of fire means what will happen? Volcanic eruption. When volcanic eruption will happen, what will happen? Temperature will change. When temperature will change, what will happen? The current which was colder can become what? Current becomes warmer in nature. So there, yes, okay, there is climate change which is happening, or global warming which is causing this change to occur, but it is also a ring of fire zone which can alter the temperature, fine. So lot of factors are there which can cause what? Which can cause nothing but okay, the change in what? Change in the nature of Peru current. change in the nature of Peru current. Lot of factors are something that are there. Fine. Clear? There can be seasonal variation. Sometimes seasonal variation also occurs, which causes what? Which causes nothing but okay, the change in current. Seasonal variation can also cause. Let's say shifting of pressure, weight, other thing. Seasonal variation can also cause this current to change. Okay, that is okay there. Clear? Like you know that polar region have 6 months of days and 6 months of night. So when 6 months of days are there, current that is going to come from the polar region will be what? Somewhat less colder. Okay, when 6 months of night is going to be there, then what will happen? Current that is going to come from polar region becomes more colder in nature. Okay, so seasonal variations are also there. So a lot of factors are there that can cause what? That can cause the Peru current to become which type of current? Warmer current. Clear? Now, when it becomes warmer, what will happen to the air? We discussed low pressures are being created, air is rising up. So what will happen? Rainfall is going to be there. So rainfall is going to be experienced in this particular region. But what will happen to fishes and marine organisms? What will happen to fishes or marine organisms? Okay, and they'll not be happy because no nutrient is now coming up. Clear? Earlier, what will happen? Nutrient used to come from nothing but okay, bottom of the ocean to the top of the ocean. So fishes and marine organisms were happy. Humans were not happy, but now humans are happy because rainfall is happening, but fishes and other are not going to be happy because what will happen? No nutrient is something that is okay coming up. Clear? So this is what okay you are finding in case of El Nino event, which is a reversal of worker circulation. Clear? So normally this region used to receive rainfall. In normal condition, this region used to receive rainfall. Now this region will okay receive what? No rainfall or less wind, and because of which type of pressure? High pressure. This region which you don't used to receive rainfall, Atacama desert, we discussed rice desert, which don't used to receive rainfall, is now receiving nothing but okay rainfall because of the formation of which current? Warmer current. Clear? Any doubt regarding this one? So this phenomena is called as what? This phenomena is called as a El Nino event. This phenomena is called as a El Nino event. Fine. Any doubt in this one? Now, why we are okay studying this particular phenomena? Because El Nino have very wide impact. Okay, it has a very wide impact. So El Nino impact, what are the impact of El Nino? First, it alter the global temperature. It alter the global temperature. First, okay, important thing that you are finding is El Nino is altering what? Altering the global temperature. What is altering global temperature means? Change in temperature of which type of temperature? Oceanic temperature. You can add altering the global oceanic temperature. So normally you see Peru region is what? Peru, along the coast of Peru, colder water need to be there, but this colder water is changing into which type of water? Warmer water, and warmer water is changing into colder water. You know that if this event happens, what will happen? If this event happens, the oceanic temperature changes, what will happen? It will affect the marine organisms. Why? Why? Remember concept of specific heat we discussed? We discussed water takes times to what? Get heated, and water takes times to cools down. Clear? While the land get quickly heated and land get quickly cools down. So on the land you are finding temperature of 48 degrees Celsius also. On the land you are finding temperature of minus 20 degrees Celsius also. Oceans you will find maximum of 27 to 30 degree, and okay around okay what around nothing but okay 0 degree to okay what 5 degree. You will see nothing but okay this okay what this variation you are seeing in the case of nothing but okay oceans. Fine. So organisms that are surviving in the oceans have narrow range of temperature. They have a narrow range of temperature survival. They can't survive in okay what? Temperature change. Why they can't survive in temperature change? Because they can survive only in this temperature range, 0 to 27 to 30 degrees Celsius. Organism on the land can survive in what? Organism on the land can survive in a wider temperature range. That is okay there. Clear? So since oceanic temperature is changing, what is happening to the organism? What will happen to the organism? They'll not be able to survive because they are adapted to what? They are adapted to only the narrow range of temperature, not adapted to nothing but okay, wide changes in the temperature. That is okay there. Clear? So this will lead to what? This will lead to ecosystem disruption. This will lead to ecosystem disruption. Ecosystem disruption. Fishes will die, coral reefs will die. Okay, ecosystem disruption. Food chain will be disrupted. Clear? All these phenomena is going to happen. So this is ecosystem disruption. Fine. Another important thing, it can bring extreme weather event. Why extreme weather event? So as we discussed, coast of Australia, which should get rainfall, is not getting rainfall. Coast of okay, what? Coast of the Southern America, which do not get rainfall due to this particular event. So it also brings what? Extreme weather event. That is okay there. Clear? Next, it also affects global precipitation. It also impacts the global precipitation. It is also impacting global precipitation. Global precipitation, how it is impacting? Like whenever El Nino occurs, India will receive lesser rainfall. Whenever El Nino occurs, El Nino create drought in India. India is going to receive lesser rainfall whenever El Nino occurs. So it is going to alter global precipitation. Clear? India will experience drought. India will experience less rainfall in monsoonal season. Then because okay, what? Because of nothing but okay, El Nino event. So it causes monsoon disruption. Now, if monsoon disruption happens, what will happen? Like in India, monsoon disruption is happening. So what will happen? Yeah, you see farmers, agriculture and crops. Agriculture or livestock, they get impacted. Agriculture crops are going to be impacted, livestock are going to be impacted because of El Nino event. They are going to be impacted. Clear? So less okay, what? Like in monsoon season, what you generally grow? Sugarcane you grow, paddy you grow, because these crops requires more amount of what? More amount of rainfall. Clear? So you grow this in monsoonal season. So there will be failure of these crops. Okay, cotton crops will get failed. Okay, you'll see the sugarcane crops. You'll see paddy crops. Okay, so these are okay. What? These crops are not going to be growing. And you'll also see livestock. When rainfall will not happen, then what will happen? You'll see grazing will be impacted. You'll also see fodder is not going to be available for whom? Fodder is not going to be available for the cattle or livestock. That is okay there. So this is okay going to create problems also for whom? Also for livestock. Clear? So it impacts both your agriculture and it will impact your livestock. So if agriculture crops are impacted, what will happen to food security? What will happen to food security? Whether food will be more or food will be less? Food will be less. So it will going to impact also your food security. Now the term food security means, if you are not aware, the three terms: availability, accessibility, affordability. Yes. So something that is okay there, then we call it as a food security. Clear? Availability need to be there, accessibility need to be there, and affordability need to be there. Clear? So if crop get destroyed, then food itself will not be available. When it will not be available, what will happen? When it will not be available, what will happen? Less supply. Less supply means what? More demand. More demand means what? Price will go up. Price will go up. When price will go up, what will happen? You see, affordability will also be not there. So it is going to impact what? It is going to impact your food security. What will the reason after this? What will happen? Yeah, perennial rivers will be impacted. Seasonal river will be impacted. So that is ecosystem disruption. We have okay. You can write that in ecosystem disruption. It can huge economic consequences. It can bring huge economic consequences. Why huge economic consequences? Because extreme weather event means what? Disaster will happen. Disaster will happen. For that, mitigating disaster, what is required? Okay, you requires nothing but okay, money. For economic consequences, if food is not available, other thing is not available, what will happen? Government has to provide food. Government has to provide nothing but okay, this one. So for that, government need more money. That is okay there. Then you will see what? You'll see farmers are going to be impacted. Farmers are going to be impacted. Government has to support farmers also. That is okay there. So it is going to bring huge economic consequences. Industries will be disrupted. If let's say the paddy crops is not growing, so what will happen to rice milling industry? They'll be impacted. If what will happen to cotton industry? They will be impacted. What will happen to sugar industry? They'll be impacted. So industrial industries will also be impacted due to failure of monsoon. So huge economic consequences are going to be there because of nothing but okay El Nino event. Fine. Also, you'll also see water resources. You can mention water resources, power generation, decline in water resources and power generation also. That can also happen. Why power generation will decline? Because rivers are okay flowing on a lesser capacity, so power generation will decline. Decline of groundwater, decline of pond water, lake water, river water, water resources will decline. So these are okay. What these are the impact that you are seeing with regard to what? With regard to El Nino. Okay, so question might come. What do you understand by the term El Nino, and how? What are the impact of El Nino? That type of questions you may get in the case of examinations. Fine. Any doubt regarding this particular part? So these are the consequences you have to keep in mind. Fine. So as we discussed, El Nino is causing what? El Nino is causing the reversal of which circulation? Walker circulation. So that's why this phenomena is called as a southern oscillation. This phenomena is called as what? Southern oscillation. Sometimes you see Walker circulation is okay like this. Sometimes you see Walker circulation is like this. So oscillating, Walker circulation is oscillating. It is happening in which ocean? Southern Pacific Ocean. That's why it is called as what? It is called as a southern oscillation. It is called as a southern oscillation. Clear? And when El Nino is causing it, when El Nino is causing this southern oscillation, we call it as what? ENSO. El Nino southern oscillation. When El Nino is causing this oscillation, we call it as a ENSO, El Nino southern oscillations. Fine. So what is ENSO? ENSO is nothing but okay what? The change in what? Change in nothing but okay Walker circulation. Okay, Walker circulation, reversal of Walker circulation and oscillation of Walker circulation. That is going to be called as which event? That is going to be called as a ENSO event. El Nino southern oscillation event. Fine. Fine. Now the question here is how El Nino is leading to lesser monsoon in India, because we discussed whenever El Nino is there, what will happen? India will face what? India will face a drought condition. So how El Nino is okay leading to lesser monsoon in India?
Because colder current will flow our side, India side, and colder current will not carry much moisture.
Fine. Any other thing? Any other thing?
Like with the passing, like the rainfall might occur in between cyclones or passing.
Fine. See, this is a normal situation. So in normal situation, we discussed, okay, here what is happening? Here what will happen? You will have nothing but, okay, more, okay, what? More rainfall. You will see nothing but, okay, more rainfall in this region. Okay, generally which type of current are going to be there? Warmer current or something that are going to be there. Yeah. Now what will happen is, okay, what? Warmer current, how the Walker circulation is happening? Walker circulation is happening like this, sinking where? Sinking on this particular region, and you'll see, okay, wind is blowing from here to here. Wind is blowing from here to here. This is what happens in a Walker circulation. So in Walker circulation, what is happening? If from here it is rising, moving in this direction, falling over where? Falling over this region. And then, okay, from here to here, which wind flow? High pressure to low pressure, a wind will flow. That is okay there. Clear? So when wind are flowing, you'll see, okay, more water is coming towards what? More water is coming towards the coast of nothing but, okay, Australia. And this more warm water will come towards also, because you see which current is moving? South equatorial current. This warm water will also be coming towards which ocean? Towards nothing but, okay, Indian Ocean region. Okay, it is going to be coming under Indian Ocean region. That is okay there. Clear? Now, if reversal of Walker circulation happens, then what will happen? You will see here colder current. Colder current means what will happen? Now the wind will, Walker circulation is what? From here to here, now wind will flow. When here to here wind will flow, so what will happen? So this is how circulation is happening. On the coast of Australia, now what will happen? The winds are subsiding. So here high pressure are going to be formed. Here what pressure are going to be formed? Low pressure. So now wind is moving away from here. When wind is moving away from here, it will take water away from the coast of Australia and bring more towards where? Bring more towards something but okay, coast of Peru region, that is okay there. Clear? So this is how you see nothing but okay, what you see, things are going to be impacted. Now if water is going away towards the coast of Peru, water is not going to come in which region? It is not going to come in the Indian Ocean region. When it is not going to come in towards Indian Ocean region, what will happen? What will happen? You don't see nothing but okay, what you don't see air picking up the moisture and causing nothing but okay, rainfall in this particular region. Fine, any doubt regarding this one? So that's why El Nino event causes lesser rainfall in India. Why? Because water is something that is moving away from where? From the coast of Australia, because of nothing but okay, El Nino event. If the water is normal condition, water is coming towards what? Water is coming towards coast of Australia. This warm water comes over here, and you know that when a warm water comes, air also becomes warm, air also becomes warm. So what will happen? More rainfall are going to be there. So that's why El Nino causes what? El Nino causes lesser rainfall, drought condition in case of India. Fine. Any doubt regarding this particular thing? So this is how sometimes okay, you see when India faces a drought in the monsoon season, it is triggered by which event? It is triggered by the El Nino event. Fine. Now there is another conditions which you find. There's another condition which you find, which is called as La Nina condition. Which is called as a La Nina condition. Clear? So we have written ENSO, we have written El Nino, and we have written La Nina. Clear? So what happens in a La Nina condition? La Nina condition is strengthening of water circulation. Strengthening of water circulation. When this circulation is strengthened, then it is going to be called as what? La Nina condition. So La Nina is opposite of whom? Opposite of nothing but okay, the El Nino. El Nino is causing weakening of water circulation. Water circulation is being reversed in case of El Nino. In La Nina, what is happening? Strengthening of water circulation is happening. How strengthening will happen? This Peru current, which is a colder current, becomes much more colder. It becomes much more colder, while the warmer current becomes much more warmer. So as a result, this circulation will be intensified. More high pressure here, more low pressure over here. So more water is going to come from here to here. Clear? So that's why this circulation is something that is okay, intensifying in what? This circulation is something that is okay, intensifying in La Nina conditions. Clear? So in La Nina, what will happen? In La Nina, what will happen? In La Nina, what will happen? Strengthening of water circulation. Peru current becomes much more colder. When it becomes much more colder current, what will happen? More high pressure. More high pressure means what? More low pressure over here. More water is going to be moved from here to here, because wind is moving from here to here. So more water will be moved from here to here. That is okay there. Clear? When more water comes to the coast of Australia, more water will come towards what? Towards Indian Ocean region. When more water will come towards Indian Ocean region, will happen? We'll see more rainfall in India. Clear? So La Nina causes strengthening of monsoon in India. It causes more rainfall in India. It causes strengthening of monsoon in India. Fine? Fine. So what is the impact of La Nina? What is the impact of La Nina? Impact of El Nino we have discussed. So what is the impact of La Nina? First thing, yeah, it is strengthened monsoon. It is strengthened monsoon. Monsoon. If monsoon are strengthened, what will happen? More good crops. So agriculture and livestock, they are going to be benefited. Okay, more good crops. Okay, agriculture and livestock, they are going to be benefited. Fine. Fine. It will also reduce what? It will, La Nina is what? La Nina is okay, creating more rainfall. More rainfall means what? it will reduce the heat wave condition. In India, you know that when monsoon doesn't come, in the month of June, when monsoon comes, okay, you see what? You see rainfall happens, rainfall will reduce the heat. Clear? Because India is facing summer in what? Month of April, month of May, so heat wave conditions are there. This heat wave condition will be minimized when rainfall happens. Okay, so in La Nina, more rainfall happens. More rainfall happens means what? It will reduce the heat wave conditions. Okay, that is okay there. Clear? Clear? So you can also add cooler temperature. It will bring cooler temperature, reduce heat wave condition, bring cooler temperature. That is okay there. Clear? Now, because it is strengthened monsoon, sometimes you may also experience flooding. So El Nino is causing drought, but it may causes what? Flood to occur, because okay, more rainfall is okay going to happen, so flooding can happen. Clear? Clear? In La Nina, what is happening? We discussed water circulation is strengthened. When more water circulation is strengthened, then what will happen? When more water circulation is strengthened, what is happening? We are seeing this is high pressure, this is low pressure, so more water will move from where to where? More water will move from here to here. That is okay there. More water will move from here to here. That is okay there. So here you'll find what? Here you'll find nothing but okay, more amount of warm water. In the Indian Ocean region, you'll find more amount of which type of water? Warm water. Clear? If more warm water, then what will happen? Will be sad. Yes, okay, that will happen. But more warm water can cause what? Can cyclonic activity. Remember, we discussed what is required for tropical cyclone? Warm sea surface temperature. So warm sea surface temperature will happen when there is a more warm water coming. So La Nina can trigger what? La Nina can trigger more cyclonic event. So it can trigger more cyclonic event. Clear? So these are the impact of whom? These are impact of nothing but okay, La Nina. That is what you are finding. Clear? So there are two events which is called as El Nino, another is called as La Nina. El Nino is what? Reversal of water circulation. La Nina is what? Strengthening of water circulation. Fine. Any doubt regarding this part? Now there is similar condition that is also going on in Indian Ocean, which was later discovered. In around 1999, we discovered the similar type of circulation in Indian Ocean, which is referred as a Indian Ocean dipole. It is referred as what? It is referred as a Indian Ocean dipole condition. Clear? So there is a similar condition, similar thing that is okay, also being observed in Indian Ocean. Reversal of okay, what? Reversal of circulation is also being seen in the Indian Ocean, and this is referred as what? This is referred as the Indian Ocean dipole. Fine. So what happens in IOD, Indian Ocean dipole? So this is a case of nothing but okay, IOD. IOD also have a two phase. You can see a positive phase and you can also see a negative phase. That is okay there. This phase is called as what? This phase is called as a this phase influences the monsoon in India. Again, IOD influences which type of okay, it influences the monsoonal rainfall in India. When we'll get more monsoon, when we'll get lesser monsoon. So normally what happens is what? Normally what happens in positive Indian dipole? In positive Indian dipole, so just now we discussed the oceanic circulation part. So you're finding this oceanic circulation part. So in the Indian Ocean region, you doesn't see much of doesn't see much of warmer current or colder current. Why? Why? Because Indian Ocean is not connected with what? In the northern side, Indian Ocean is not connected with the polar region because landmass is present. So that's why Indian Ocean is not connected with what? Polar region. Here in Pacific Ocean, you can see this is connected with what? Polar region. Here Atlantic, you see it is connected with the polar region. So that's why here you see nothing but what? Here you see nothing but circulation is happening. But in Indian Ocean region, you don't see much of circulation of what? Warm or colder current. Only in the southern part, because southern part is connected with the Antarctica, you see here colder current are there, here nothing but which type of current are there? Warmer current are there. Clear? So normal situation is what? Normal situation is you find the warmer water where? You find warmer water over here. Because of which current? Because of warmer current. Okay. And colder water you're gonna find where? On the Australia, on the Indonesian side, you will find which type of water? Colder water you're going to find over here. Clear? Why? Because which current is coming? Cold oceanic currents are something that are coming. So normally in the Indian Ocean region, you will find warmer water, okay, this side, and colder water towards something but okay, this side. Clear? So what happens in, okay, what happens in a positive IOD conditions? So what happens in a positive IOD conditions? So you can find normally what is happening, we discuss warmer water is going to be where? Towards Africa, and colder water is going to be where? Towards Australia. So this side, Australian side, you are finding which type of water? Colder water. So blue color is indicating which type of water? Colder water. The red color is indicating which type of water? Warmer water. So normally warmer water will be here, colder water will be nothing but okay here. So as a result, air becomes okay warm where? Air becomes warm over here, air becomes cold over here, air becomes cold over here. So warmer air, you know that it rises up, colder air, you know that it sinks down. So which type of circulation is happening? You see nothing but okay, this type of circulation is being formed. Clear? So whenever there is this type of circulation, it is called as what? It is called as a positive IOD. Okay, so this is called as a positive IOD. Clear? So normally we discussed, okay, here what you'll find, which current you'll find? Warmer current. Here which current you find? Colder current. So as a result, warm water is present over here. Which type of water is present over here? Colder water is something that is present over here. This colder water will make air cold. So cold air will sink down. This warmer water will nothing but okay, make air warm. So warmer air is nothing but okay, going to rise up. Okay, that is okay there. Clear? Now, if this circulation is reversed, then it is going to be called as what? It is going to be called as a negative phase. Now, in negative phase, what will happen is warmer water will now come towards this side, and colder water will now come towards nothing but okay, this side. When colder water comes towards this side, air becomes cold. When air becomes cold, what will happen? You will see sinking down. Here air becomes warm. So what will happen? You'll see nothing but okay, rising up. Clear? So this circulation is called as what? This circulation is called as a negative phase of IOD. Clear? So the same phenomena that we discussed happening in what? Happening in the southern Pacific Ocean is also happening where? Also happening in the Indian Ocean, where it is referred as what? Where it is referred as the Indian Ocean dipole. Okay, so during the positive phase of this dipole, you'll see warmer water over here, and you'll see more rainfall. More rainfall happens where? More rainfall happens on the western side, less rainfall will happen on the eastern side. So less rainfall in this condition. So coast of Indonesia, coast of Australia, they will receive lesser rainfall. You'll see India, you'll see Africa, African coast, they will receive nothing but okay, more rainfall. because okay, warmer water is something towards this particular side. Clear? In case of what? In case of nothing but okay, negative, you see warmer water is shifting over here. So coast of Indonesia, Australia, they are going to be nothing but okay, receiving more amount of rainfall. And what you see is okay, African coast are going to receive what? Drought condition. Even India is going to face okay, which type of condition? Drought condition. Clear? So negative phases create what? Drought in India. Positive phase create what? More rainfall in India. Positive phase create what? More rainfall in India. Fine. So this is basically the case of Indian Ocean dipole. Fine. So negative phase create what? Negative phase create more drought condition in India. It create more rainfall on this coast and less rainfall on this coast. So that's why India faces a drought. Positive creates nothing but okay, more rainfall over what? More rainfall okay on this side, less rainfall on this side. So that create more rainfall in India. So that's why monsoon in India is very complex phenomena. You see El Nino, it is influenced by whom? It is influenced by El Nino, it is influenced by La Nina, it is influenced by what? Positive IOD, it is influenced by what? Negative IOD. So that's why it is a very complex phenomena how the monsoons are something that are formed in case of India. Fine, any doubt regarding this particular thing? So why do you see why do you see warmer water over African coast? Because warm current is flowing. Why do you see colder water at Australian coast? Because cold current is flowing. Clear? But sometimes okay, when this situation reverses, then what will happen? Here warmer water, here colder water. It is called as a negative phase, and negative phase create which type of condition? Drought conditions. Clear? Any doubt regarding this particular part? Now, what important thing that you have to keep in mind is here rise which type of desert? If you remember, which desert lies over in Australia? Kimberley is a plateau. Kimberley is a plateau that lies in Australia. Which desert lies? Which desert lies? Remember, we discussed Victoria Desert, Gibson Desert, Simpson Deserts. Okay, those deserts are something that are being found where? Those deserts are being found in the case of Australia. Why? Because normally, normal situation is what? Normal situation is you don't get much rainfall, okay, in this condition, in this region. But when reversal happens, then you can see a rainfall in this particular region. Clear? So which type of deserts you are seeing in case of Australia? You are seeing the Victorian Desert, Gibson Desert, Simpson Deserts. Those deserts we have discussed, which you found, like Atacama Desert over here. You'll find these type of desert in case of nothing but okay, Australia. So sometimes okay, you'll see more rainfall in this particular region. Clear? So if El Nino event is occurring, along with that negative phase of IOD is there, then what will happen? If El Nino event is occurring and along with that negative phase of IOD is there, then what will happen? Then severe drought. Then what will happen? Very severe drought will occur because El Nino is also reducing rainfall and negative phase of IOD is also reducing rainfall. So what will happen? It will lead to severe drought condition. It will lead to severe drought condition. But if El Nino is occurring and positive IOD, then what will happen? If El Nino is occurring along with the positive IOD, then what will happen? So as we discussed, El Nino will try to create a drought, but positive IOD will bring more rainfall. So as a result, what will happen? Severity of drought will be minimized. Severity of drought will be minimized. Severity of drought will be minimized. Fine. So if El Nino is occurring along with the negative phase of IOD, then what will happen? Severe drought condition is going to occur. If El Nino is occurring along with the positive phase of IOD, then what will happen? The severity of drought will minimize. It will get minimized. Fine. Any doubt regarding this one? So that's why, okay, in the case of what? In the case of newspaper and etc., you'll find constantly these terms: El Nino, positive IOD, negative IOD. You will constantly find these particular terms. Fine. Now you can see last monsoon, it's saying positive IOD may re-emerge this year. It's saying positive IOD may emerge this year, likely to boost which type of monsoon? Southwest monsoon, which causes monsoon wind in India. So what is IOD, positive IOD? As we discussed, positive IOD brings more rainfall in India. But last year also you saw what? It's saying El Nino hangover to continue. IOD may remain silent during nothing but monsoon, or how El Nino can impact India's economic progress in financial year 2024. So as we discussed, El Nino is causing what? El Nino is causing a drought condition, and this drought is leading to, as we discussed, huge economic consequences. So when huge economic consequences are there, then what will happen? India's economic growth will decline. That is there. But this El Nino is coupled with which type of phenomena? Positive IOD phenomena. This El Nino is coupled with which type of phenomena? Positive IOD. So we discuss severity of drought will what? Severity of drought will minimize. Clear? So this is what you are finding with regard to nothing but El Nino and positive IOD concept. So remember that whenever El Nino and the IOD will occur together, you will see, you have to see whether it is a positive IOD or negative IOD. If negative IOD is occurring along with the El Nino, severity of drought will increase. If positive IOD is occurring, then severity of drought will get minimized. Clear? So this is all about El Nino, La Nina, ENSO phenomena, positive IOD and negative IOD. Any doubt regarding this one? Now we are coming to the world climatic classifications.
Sir, why
Yes.
is
Why La Nina is occurring? Because Peru current is becoming much colder in nature. Why Peru current is becoming much colder in nature? Why Peru current is becoming much colder in nature? Seasonal variation. If polar region is more colder, then what will happen? More colder current will come. So the Peru current becomes much colder. Second is what? Global cooling. If more amount of volcanic eruption happens, then what is released? Which gases is being released? When more amount of volcanic eruption happens, which gases is being released? Nitrogen oxide and sulfur oxide. If you remember, SO2 is which kind of gas? It causes global cooling. SO2 causes which type of cooling? Global cooling. More ashes, more dust in the atmosphere, what will happen? Because volcanic eruption create what? More ashes, more dust. Solar radiation will get will not enter to the earth. Solar radiation will get minimized because the dust particles and other will reflect what? Sunlight. So as a result, what will happen? You will see earth will cool down. When earth will cool down, what will happen? Polar region will further cool down, and as a result, current becomes what? Colder in nature. Clear? So those phenomena can cause nothing but the La Nina event. Fine. Next comes to your world climatic classification. What are world climatic classification? Primarily, we classify the world climatic thing
normal circulation, you said before, I don't know if it's thermocline circulation, both are same.
No, thermocline is basically the temperature gradient. We'll discuss that in oceanography. When you are moving from upper region to lower region, what will happen to the temperature in water? Temperature in water will decrease because this region receives more amount of sunlight. This region receives nothing but lesser amount of sunlight. So when you are moving from this region, a sudden region is there where you see quick changes in what? Quick changes in temperature. Clear? You will see sudden region where quick changes in temperature is occurring. Here warmer temperature, here colder temperature, a quick changes in temperature is occurring. This is called as a thermocline region for that is. So Both are different. Both are different. Thermocline will take up in case of oceanography. So thermocline, pycnocline, all these are terms we'll discuss in oceanography part. So the quick changes in temperature occurs. Here warm temperature, here colder temperature is going to be fine. So tropical grassland climate, then you have desert. So this is how you see classification of what? World climate. Clear? So they are classified into total of 11 type. We are classifying them in the total of 11 type. These are equatorial rainforest climate, tropical monsoon, tropical grassland type of climate, desert climate, temperate monsoon climate, China type, temperate grassland type, Mediterranean type, Laurentia type of climate, Siberian type of climate, British type, and tundra type of climate. This region is referred as equatorial region. This is tropical region, warm temperate zone, cool temperate zone, and polar regions. We'll discuss. There are a lot of questions that has been asked from this topic. We'll discuss what is the characteristic of each type of climate, when wind will blow, when which type of occupation you can do, which type of other thing that you have to do. So everything we have to discuss regarding this type of climate. So in NCRT, if you read, there are certain names that are mentioned, there are a lot of the people who has come up with what who has come up with the concept of climatic classification. How to classify the climate? There are a lot of people who has come up, okay, with the name. Like there is a person called Koppen, Koppen. Koppen has come up with this climatic classification. Thornewhite has come up with climatic classification. So a lot of names you will find in case of NCRT while reading the climatic classification. But those are okay, but those are not going to be much asked in case of examination because those are part of geography optional. Will not be asked in GS paper. That is okay there. So we are not going to take up the Cope and Thornewhite. Names are mentioned in NCRT, but okay, the classification in detail will not be finding. Clear? So those, when you take geography as an option, you'll find that okay, classification also, different type of climatic classification. For GS paper, this okay, climatic condition classification, you just keep in mind. Equatorial rainforest, tropical monsoon, tropical grassland. Tropical grassland is also known as a savanna climate. Now, China type, steppe type, Mediterranean type, Laurentia, taiga, British, and tundra type of climatic conditions. Fine. Now, in between 10 to 30 degree latitude, on the eastern side, you find which type of climate? Tropical monsoon. On the western side, you're going to find which type of climate? Deserts. And in middle, you're going to find which type of climate? Grassland type of climate. Similarly, on the eastern side, you're going to find temperate. On the western side, you're going to find what? Mediterranean. In the middle, you're going to find which type of climate? Grassland type. On the eastern side, you're going to find Laurentia. On here, you'll find Siberian. Here, you'll find which type of climate? British climate. Fine. For example, if you see India, so you can see this is a figure for whom? This is a figure for British type of climatic conditions. So where you are finding British type of climatic condition on the western margin. Okay, so we have written British type of climatic conditions are found where? On the western side. On the eastern side, what you're going to find? On the eastern side, what you are finding? The same latitude you are finding Laurentia type of climate. So you are finding same latitude, which type of climate? Laurentia. Here what you are finding? Taiga type. We have written taiga type of climate that you are finding. Fine. Like that. Okay. Here in India, western side, what you are finding? In India, western side, what you are finding? Desert, Thar desert. Eastern side, what you are finding? Monsoonal climate. More monsoon happens, okay, in this region. And in between region, okay, what you're going to find? Grassland type of nothing but, okay, climatic conditions. Clear? So this climatic condition is based on, okay, which is lying on the western side, which is lying on the eastern side, like Mediterranean region. You see Mediterranean region, west side, Mediterranean climate. On the eastern side, China is there. So China type of nothing but okay, climatic condition. So this climatic condition is based on what you are going to find in which particular region. Fine, any doubt regarding this one? So we'll start with the characteristic of these climatic condition in tomorrow's class. Fine, any doubt regarding this one? So what we try to cover today is what? Temperate cyclone, the differences that occurs between whom? Differences that occurs between tropical cyclone and temperate cyclone. Remember front formation. What are the different type of fronts we have discussed? What are the different type of front? Stationary front, warm front, occluded front. Yes, okay, those things. Then what we have discussed? We discussed concept of Elnino, Lanina, impact of Elnino, impact of Lanina, IOD condition. Remember IOD, Indian Ocean Dipole condition. And finally, world climatic classification part. Okay, thank you. Thank you. After this, okay, we will be having one more topic after class.